Days, knowledge is money. All right, here we go. So, what question are we on? 8C. Perfect, perfect, perfect. 8C. I knew it was like 8 some. I just couldn't remember. All right, this one says to draw a diagram to illustrate the opposite of the vector v, and then find u minus v using the parallelogram. All right, what was v originally? What would the opposite of vector v be? All right, so this question's a little different from the other two. It first wants you to illustrate the opposite of V. So I'm going to first graph that. So that's going to be left 4, down 3. So there's my opposite of V. Then it says find U minus V. So that means I need to first graph U. What was U? Thank you. So I'm going to go left 2, then up 1, 2, 3, 4, 5. So here's my U. And then now to do the minus V, I'm basically going to graph that opposite of my vector V. So from the tip of U, I'm going to graph negative 4, 3. So that means I'm going to go 1, 2, 3, 4, and then down 1, 2, 3, which was me, I don't know, somewhere like here. And if you kind of see, what do you notice about this opposite V in blue and the opposite V in red? They're the same length and the same direction, right? Or they should be. Our tallies might be a little off, but they're basically parallel. They're the exact same direction. They're the exact same length. So to find the u minus v, now I just figure out what is this coordinate here. So what's this guy? Good, negative 6. And I would argue 2, yeah, positive. There you go. So I first wanted you to graph the opposite of v, and then to graph the u minus v, you kind of see the correspondence there. If we could have picked that graph up, we could just attach it there. Go ahead. So which part? The opposite of v or u minus v? So I graph the u, and then to figure u minus v, I then attach the opposite of v, that's what minus v would be, to the u. So that's how I got to this point. This would be the u minus v, so this would be the answer that I was looking for. That would the vector, which is the direction and well, give you the distance, but you would have to do the square root, but we don't need that. We just really need the direction. All right, any other questions on that? All righty. So again, that one just had you do 2 different graphs. Part D does kind of the same thing. It asks you to graph both 3V and the opposite of 3V. So let's look at that real quick. So to do this graphically, you start off by just graphing V. What was V again? Thank you. So I'm going to start off by using 3V first. So to do that, I'm going to graph 4, 3. So that's 1, 2, 3, 4. 1, 2, 3. So there's 1V. And then I'm going to graph another V on top of that. So that's 1, 2, 3, 4. 1, 2, 3. There's a second V. And then from the tip of that one, I'm going to draw another V. So 1, 2, 3, 4. 1, 2, 3. And there's a third V. My last class actually asked, or sixth period yesterday, asked, why can't I not just graph straight up 3V? Well, the idea is you're using the parallelogram theory, which is actually graphing these vectors and letting it land on the answer. So yes, you are technically just drawing out 3V, but you're doing it by section. So like on the test, you're going to be asked to do that same thing, a vector attached to a vector attached to a vector. That will then lead you to the answer rather than just one long answer. So in this case, 3V would be what? Perfect. And you can do that algebraically to verify as well. Now I want you to graph the opposite of 3V. And it's going to be the same part. We already know the opposite of V ended up being what? That would be the final answer. What was the opposite of V from the previous question? -4 and -3. Perfect. So with that, I'm just going to graph that one 3 times to get my opposite of 3V. So that's 1, 2, 3, 4, 1, 2, 3. So there's 1, and then 1, 2, 3, 4, 1, 2, 3. There's 2, 1, 2, 3, 4, 1, 2, 3. So now I've graphed a -3V as well. And what did I get for the -3V? Perfect. And again, you can verify using the algebra as well. And bless you. Is there any other questions on how to graph it using the, what they call the parallelogram way? So really all that means is just graphing it. All right. Then part I to D, these two questions are only looking at part D. How do these two magnitudes of these vectors compare to one another? So how does 3V and -3V compare to each other on their magnitudes? They're the same. What's magnitude mean? Distance from the origin. Oh, I like that. So this right here, even though they're going in opposite directions, they still will have the same magnitude. So 3V and -3V will have the same magnitude. All right, part 2 there says, how do the directions of 3V and -3V compare? Good. My bad, I forgot that part. How do they relate then also to V? There it is. They're 3 times or they're tripled. So the 2 are 3 times as long as vector V. Very good. All right, then part 2 then says, how do the directions of 3V and the opposite of 3V compare to the direction of V? That would be distance. So like, let's take 3V. Compare 3V with the direction of V. Or is there any difference? Good. It's the same direction. So 3V is the same direction. It's just longer, but it's still going in the same direction as V. What about -3V? Is it the same direction? It's the opposite direction this time. Any other questions there? Is there more on that? I think it's 9 and 10. All right, so in 9 and 10, we're just going to talk about this in 3-dimensional space. It's actually treated the same way as 2-dimensional space, and I am not going to try to waste my time trying to graph these. We'll just do it algebraically because I hate graphing 3-dimensional vectors. On the test, you're not doing a 3-dimensional vector graph. You're just doing a 2-dimensional, but you are going to do the algebra part of it. So let's make sure we can do that. When I ask, what is the component form of this? What is this called? Do you remember? Well, it is a vector, but it's called what? Not an AB vector. But it is a vector. What is it called? It has a different name. Good. This is called a directed line segment, which is a vector. So when I'm trying to figure out the component form of AB, notice it's the same pattern. We're still taking the second, or the, what they call it, the terminal point from the initial point on each one of these, but now there's a third one for a Z. So when I'm looking for the component form of this guy, I just take the terminal point, which is the second number, minus the first number. So in this case, this is going to be 2 minus 1. -3 minus 0, and 6 minus -5. And when we do that, what's 2 minus 1? 1. What's -3 minus 0? And 6 minus -5. Heard it? 11. Two negatives will make a positive, so this will be 11. But notice it's the same process as two-dimensional. We just have that third number there. So to find the magnitude of this directed line segment, how do you find the magnitude of a three-dimensional vector? There it is. So it's going to be the square root of x squared plus y squared plus z squared. I think in our books we also used a, b, and c, but same process. So this will be 1 squared plus -3 squared plus 11 squared. What's 1 squared? -3 squared? 11 squared? 121. Very good. 1 plus 9 plus 121? 131. I'm pretty sure 131 is a prime number, so we can just stop there. Questions on how to find the magnitude of a three-dimensional vector. All right. Last question. And then we'll jump into lesson 21. Again, we're going to skip lesson 20. So in lesson 10, it says consider the points A, B, and C. We're going to show that the vector A, or the directed line segment AB plus the directed line segment BA does equal 0. We'll talk about the explaining of it later. So first, we need to figure out the directed line segment AB. I think these are the same points from earlier, are they not? All right, so we already did AB. What was AB? All right, so now let's just go find BA. So this time I'm now going to take A and subtract it from B. So 1 minus 2 would give me -1 in part A. Yes, sir. So 0 minus -3 was 3. Good. And then -5 minus 6 would give me -11. So we can tell, we should know that these are the opposites. So to explain this, we just add these two directed line segments up. So 1 plus -1 gives me -3 plus 3 gives me, and then 11 plus a -11 gives me 0, which then explains it going back to an origin of a three-dimensional space. You can just explain it in words that you have one, and then the BA would be the opposite of AB, so then it would come right back to its origin, something like that. But again, I think on the test, I don't have any of it explained by geometric for three-dimensional space. All right, then part B there, show that AB, BC plus CA equals 0 and explain your answer. So we already got AB. That would be 1, -3, 11. Now we got to go find BC. So again, this will be 3 minus 2, which is 1. 1 minus -3. 1 minus -3. +4. And then -2 minus 6. -8. Very good. And then let's do CA real quick. So now I'm going to do A from C. So now it's 1 minus 3. Yes. Yep. So on BC, I'm going to take my C answer. So this would be 3 minus 2. And then for BC, and then this would be 1 minus -3. And then this would be -2 minus 6. And then for CA, I'm going to start off with A. So this would be 1 minus 3. 1 minus 0. And then -2 minus -5. So then we just work it out. What's 1 minus 3? -2. 1 minus 0. 1, and then -2 minus -5. +3, because this right here would make a positive, so therefore the 5 would be bigger, so it'd be a +3. And now we're just going to see, does it equal 0? Let's add them up. What's 1 plus 1? Plus -2. 0. So that's the first one. -3 plus 4? 1 plus -1? 0. Oh. Yes, did I make a mistake? So that'd been A. Oh, you're right. It should have been 0. Oh, you are right. I did the first one right. You're right on the -3 then. Because this would be, it's AC, so it'd be 1 minus 3, 0 minus 1, and then -5 minus -2, which does give you the -1 and the -3. Yeah. So now, -3 plus 4 gives you the 1, right? Plus the -1, which will give you 0. And then 11 minus 8 gives you, plus -3 gives you 0. Perfect. So that was my bad. For some reason, I did the first one, and then I went backtracked and did AC. Any questions on vectors, on adding, subtracting, or graphing two-dimensional or three-dimensional? Or any scalar multiples of either one of those? Mainly the graphing part. I feel like we've done a lot on the algebra part. All right. Let's skip now to, again, lesson 21. Not right now, no. We got enough daily work right now. All right, so in this opening exercise, it says find 3 different ways to write the equation that represents the line in the plane that passes through these 2 points. If you need 3 different ways, there are. You have what they call the slope intercept, which y'all know as what? They have what they call the point slope. You want to know that one? That's standard form. That'll be the next one. But this will be y minus y1 equals m times x minus x1. It's actually formed from the slope formula. And then your last one is the standard form. What's the standard form? AX plus BY equals C. We don't have a Z in this situation. It's linear. Go ahead. That's Y1. So Y minus Y1 equals M times X minus X1. So those are the 3 equations that were kind of given to you back in algebra decades ago for y'all, since you are so old. All right, so these are the 3 forms they're going to want you to write it in. We'll start off by just simply doing what? What do I need to do first to be able to write an equation of a line when given 2 points? So when given 2 points for an equation of a line, what do you have to do first? Huh? Find the slope. So let's do that. Wait, how do you find the slope? Perfect. I like it. I like that way you put the subscript there. That's good. I just call it just x2. All right, but yes, it is x2 or subscript 2, or not x, sorry, y. Y2 minus y1 over x2 minus x1. You learned this in multiple different ways. You learned it by the delta of y over the delta of x, which is just the change or the difference between them. Or you did rise over run if it was a graph of some sort. But if given actual 2 points, this is how you do it. Now, how you label this is completely up to you. I just go from left to right. So this would be x1, y1, x2, y2. But if you label the first point x2 and y2 and the second point x1 and y1, you're still going to get the correct answer. But that's just how I form. I just go left to right. Once you have that, just simply plug it in. So it's going to be -1 minus 2 over 2 minus 1. What's -1 minus 2? -3. 2 minus 1, 1. So what's -3 divided by 1? -3. You now have your slope. What's the other thing I'm missing? Y-intercept. How do you, was it a bless you? I think it was a call. Bless you too. Yeah. Oh, it's fine. All right, so okay, how do you find the y-intercept? There's like a couple options, but I'll take one. Use the slope intercept form. How are you going to use the slope intercept form? The y equals mx plus b. Solve which one? B. Good. B would represent the y-intercept. Now, when you are plugging this in, it doesn't matter which point you use. Again, I naturally just default to the first one, but you could use the second one if you wanted to. So here we go. To put this in the slope intercept form, I'm going to use the slope intercept form. So that would make it 2 equals -3 times 1 plus b. But before I move on any further, does everyone understand where these numbers just randomly appeared from? I'm actually using the first. So y is going to be 2. So I plugged it in there. My m, I just calculate -3. My x is 1. And then plus b, I don't know what b is. That's what I'm solving for. All right, so let's work that part out. -3 times 1 gives me, how would you solve for b? Add, add -3. No, it'd just be add 3. You could technically say subtract -3. That would have been correct. That would have been kind of a cool, interesting way to say it. But then that would just give you 5 equals b. Now that you have your b, you have your m. Go ahead. You could put this in point slope form as well to calculate. Yes, yeah, it would. So just real quickly in our heads, plug in -1, and then this would be -3 times 2. -3 times 2 is -6, and then you would add 6 to the -1, and then -1 plus 6 would give you 5. So it works out either way. I just default to the first coordinate I see, but in reality, you're technically supposed to kind of look at it and go, which one's the easier numbers? In this case, I think they're all about the same there. All right, so here's our first equation. That's what it wanted us to do. Y equals mx plus b. What's my equation? Oh, we're not going to plug in y next this time. Just the m and the b. There you go. There's question number 1, or equation number 1. Equation number 2, just pick a point. Again, you can pick the first point if you would like. How would you rewrite it in point slope form? Ooh, y minus y1. What would be y1? 2. Very good. Perfect. And if you actually work that out, that does go right back down to y equals -3x plus 5. Number 3, ax plus by equals c. How do I get this guy into standard form? What would I have to do? How would I get slope intercept form into standard form? There's only one step. We can have the c, but notice the form. I have an x and a y on one side. I would move the x, leave the y there since this is technically going to be the c. But when I move this -3x, it becomes a what? So this now is 3x plus y equals 5. You now have 3 equations that represent the exact same line. Part B now just simply says, now graph the line through these points with slope 2. It's not even the slope we got. Oh, it's a whole different question. I was about to say, this is not even this. Okay, gotcha. Sorry. So we're going to graph the line through the point 1, 1 with slope 2. So this is simply just graphing. So you start off by graphing the point. So there's 1, 1. How does the slope tell me to get to the next point? Okay, go up by 2 and over 1, what direction? To the right. Very good. Slope is the same thing as rise over run. Any whole number can be put into a fraction by simply putting a 1. So you either go up or down first, and then I always teach go to the right. So if it has a negative, apply it to the top so that you go down and then always to the right. So in this case, you would rise 2 and then run 1. Once you have 2 points, can that physically make a line? Yes, it only takes 2 points to do so. There you go. So this one did not ask me to write it out. It just asked me to graph it. Any questions on old school algebra 1 there? Yeah, absolutely. Then you can get a second point. And then really with that, actually, given this point and this slope, I would just plug it straight into y equals mx plus b to calculate my y-intercept. And then I would just then work it back out to my y equals mx plus b. Technically, what happens is when you do the y equals mx plus b, you're doing a shorthand of the point slope form. Is that typically you would use this equation when given a point and a slope. And that's what we used to use back in the day before we realized the slope intercept is just a shorthand of the point slope. What's nice about the point slope formula is when you do work it down, it'll work down to the answer versus the slope intercept only gives you the b, and then you'd have to back substitute the m and b back into the other equation. But any questions on this algebra review? Hopefully it's a good start. All right, in exercise 1, it now says consider the line L, just gives it a fancy little L symbol, in the plane given by the equation 3x minus 2y equals 6. We're going to consider this line, and we're going to sketch a graph of the line on this axis provided. Oh, there's the assumption. This might be where I backtrack. Y'all don't have another question, do you? Like it goes from open exercise to exercise 1. It says to use your second open exercise, and there isn't one. That's what I was thinking, but it's a whole different formula. Not the same as neither one of them. Oh, technically that's where the form is, yes, but that's not where I'm heading with it. It's always taught that you're given one parametric equation. Okay. All right, so let me get back to that. I'm gonna shorten that up a little bit. All right, so number one, we're gonna sketch the graph of the line on this axis here provided. So how would I sketch this graph? Make it make sense. How do we make it make sense? Get it in the slope intercept, right? So I can find the y-intercept and then I can use the slope. Go ahead. It does. It gives it to you in what form? Right, but you can pull what out of there? How are you pulling the slope out? Nope. No. You can pull the x-intercept and y-intercept pretty easily, but you cannot pull the slope as easily. You would have to turn the standard form back into slope-intercept form, which is y equals mx plus b. Then you would know the actual slope. Now, there's a quick hand on finding the slope from standard form, but then you would have to know the formula as well. So in this situation, how would I get this back into y equals mx plus b? Move the x, so I now get negative 2y equals negative 3x plus 6. Then what? Then divide by negative 2. So this gives me a positive 3 halves x minus 3. So what number is my first point there? Would that be a point? Not quite. What is your 3 halves? It's your slope, which just gives you a direction of where to get the next point. Which one of these numbers is a point? And what point is it? It's the y-intercept. So it looks like this graph here. Y'all got a graph on y'all's page? It looks like it's going by twos. So if this is negative 2, negative 3 would be about right there. Now I can use the slope to tell me how to get to the next one. What does 3, 2 tell me to do? So up 3 would actually take me here, and then over 2 would take me here. Does 2 points make a line? It does. I'm going to connect those points right there. Part B then says find a point on line L that and the slope of line L. So we found a point. What was our point? Ooh, I like that. So you could technically do 0, negative 3 is where I was heading, but then you could use 2, 0. I'll take that one as well, right? Because we did find that point. That's perfect. That's either one would have been fine. Find a point on line L, and then what was the slope? Perfect. 3 over 2. Now, any questions so far? All right, this is where it gets interesting. So look at part C. Part C wants you now to write a vector equation for the line L using the information found in part B. So we found 2 points. I'm not going to use, I might use both. I don't know. 0, negative 3, and 2, 0, right? And then we saw that the slope was 3 halves. Okay, so that's the information we just discovered on our linear equation. And now we're going to write it as a vector equation. So here is the standard form. I'm just going to write it with just letters over here. Your xy is going to equal x1, y1 plus ab times t. Now catch this. Your AB is also related to your slope. So as a side note, let's see, and where to put this? We'll look at this here. The slope is B over A. So with a point and a slope, we can now write this in what they call a vector equation. So in its simplest form, we're going to write this in respect to time, meaning when I write it like this, and I'm just going to simply plug it in, and you can now use either point. You can use this one or an infinitely other points that were on that line. You get to decide what you're going to choose. I'll stick with the first one, but if you want to use the second one, that's fine too. X1, Y1 will be your coordinate. So in this case, that would be 0, -3, plus pull your information from your slope. My slope was 3, 2. So that means my B is 3 and my A is 2. So when I relate it over here, this will now be 2, 3, and then T. And so what this does for me is in respect to time, you just made two equations. X equals 0 plus 2t, and y equals -3 plus 3t. So if I had time, let's do that. I'm just going to scroll up, not erasing any of the information. I just need that graph again. All right. More space. Yeah, that works. Let's say I wanted to graph this at time 0. To do that, we can make, this is how I teach it in college. You would have time, you have your X, and you would have your Y. Typically what we do is we give you at least one parametric equation, but you are building this from the ground up. Go ahead. It's actually going to fall exactly on that same graph. So if you just want to add a table next to the graph, was there room next to it? I don't know how much work. Yeah, just build a table. This is what we call a parametric equation. Parametric equation table. What it does, it just helps us organize our information. Again, typically, at least the way I've always taught it, is you're always given one parametric equation, and then you would plug it into the other equation to find its parametric equation. And the goal is to put both letters X and Y in an equation with a letter T in it. So that when I give you time, you can simply just plug it in and it'll give you coordinates. These coordinates should fall on our graph. If not, we did it wrong. So let's see. So I want to plug in 0. When I plug in 0, what does X equal? 0. When I plug 0 into Y, what does Y equal? -3. So when I plug in 0, that's going to be -3 plus 3 times 0. It would 0 out there, but the -3 here. So I'll do it one more time to show you what that is. We about to leave? Oh my gosh. Okay, we'll pick back this up tomorrow then. But what I was going to show you was this. It's like you would go 0 plus 2 times 0, and then -3 plus 3 times 0. So that's what I was doing there. So this will give me 0, and this will give me -3. And then what we'll do is we'll keep going with our second. So that gave us the coordinate 0, -3, which was the very first point we graphed. And then we would do t equals 1, and then t equals 2, and so on and so on. And then with these points in time, it would make the same line in a parametric way.